Hi everyone, good to be here. And so today this is projecting the win team, projecting the win, and we are working on the challenge 3. So we're also going to be discussing today about the risk mitigation and approaches. So the main problem statement is we have a client who has got a manual risk management process. So you have this raw data, noisy data, messy data with a lot of different missing inputs. But the idea is we're trying to look at different risks, identified risk titles, and also try to map them to risk mitigation approaches and want to see what risk mitigations lead to a successful outcome or an unsuccessful outcome. So for this work, we create two products. The first product is an AI classification model to predict a mitigation outcome based on input data. And secondly, we have also an AI chatbot, which is interactive that could help for project management professionals to leverage AI to improve the efficiencies in their risk mitigation processes. So our task was divided into 4 stages. First, the data pre-processing, where we clean up the data, add up some new additional columns or variables that would help us to be able to track effective mitigations. Then after this has been done, we also do some data analysis to observe trends in the historical data and see how they could inform positive outcomes. Next one we do is to use the AI models for the classification to have an outcome prediction and also the interactive chatbot.
In order to effectively leverage the products that we have developed, we need to give them usable data. At the moment, the data that we were started out with, the raw data, was noisy and lacking structure. Specifically, 65 of the rows were corrupted, which we had to eliminate. 10,000 of the rows were missing data, which we had to fill in the blanks for. And the structure was not ideal in terms of the risks, the specific risks, and their mitigations were not initially automatically aligned. So we had to do those 3 things. And for details on how we did this, please refer to our documentation. But as a highlight, we also added a new data point, which was the cost value prediction, which was the main driving force to enable our model's reasoning capabilities.
So now that we have our data, the next problem now is what do we observe from the extracted data? So we're looking at a couple of questions. We want to see the impact of the mitigation actions on the cost risk and how if these actions could lead to a successful mitigation or an unsuccessful mitigation. So we created using Python, we have a dashboard which we have created, and what this does is so we can have a scroll down menu. Everything about the code is actually it's been submitted for this project. So we have different companies with their projects and the risk IDs. So for each selected, so we select a risk ID and we can look at the trend for every time that this risk has been evaluated in the data set. So if we look at any take point, we could see the report dates. We can look at the mitigation outcome if it was positive, if it was improvement or worsening. We can look at the actions, the mitigation actions that led to this improvement, and also look at the you could look at the data. What this does, it helps with the managers to be able to identify. So for instance, if you look at the last point where we see that there's a degradation, the project manager can be able to observe what were the different or the additional mitigation actions that would have led to a degradation in performance. So this can help in optimization of mitigation actions. So this can be done for any different tasks, as you can see from this dashboard.
So in the next slide, we're showing the performance of our solution. So one of the solutions we developed was a classification model that predicts the performance of our different mitigation action on the rates. We could see the performance of our model has accuracy of about 99%. In the next slide, I will show you how we're able to address some of our business users' pain point. One of the questions they want to ask is what are the factors that contribute to successful mitigations? We could see how our solution was able to address that. Then also one of the other questions they are trying to address is that what are the factors that also contribute to unsuccessful mitigation? So this slide shows how our model was able to address those questions. In the next slide, my colleagues will be addressing how our solution responds to some of the panel's questions.
Yes, we did. For example, there are up to 10,000 instances where a risk didn't have a mitigation applied to it. Our chosen strategy was to apply the strategy of that risk as the mitigation. So for example, if the strategy was to avoid, then the mitigation was filled in to be as avoid. In our real world scenario, we would discuss this with stakeholders to decide what would be the actual best approach. For more information on the full data fill in, then please refer to our documentation.
Okay, so for question 2 as well, so with the visualization output, which we showed before, which shows the trend in the different outcome, that actually also could help project managers to track. So once you're able to check each individual report date, you can see the different mitigation actions and if they were successful. So in this way, it could actually provide much room for review where the project managers can review certain mitigation outcomes and know which one is more effective in reducing or in optimizing or will lead to bad performance in the outcomes. So for the other ones with question 2 and 3, we'll use the chatbot.
Okay, so here we can see the chatbot working in real time. We've typed in this query ahead of time just to save time a little bit. So behind the scenes, this chatbot is using the clean and pre-processed data that Mikhail talked about, as well as a prompt that was engineered by our team. And here we can see that it's able to give a custom output based on the data in that table, talking about the cost, scope, and well, hopefully cost, scope, and schedule. As we can see, it's talking about scope creep, and about cost reductions, etc. So this is able to meet our third judge's question. So thank you very much for listening.